Hello, this is your question 5 in your June 2022 mechanics paper from Edexcel, and it's a projectiles question. So you have a golf ball that is at rest at point A on the horizontal ground, is hit and initially moves at an angle alpha. This is the angle of projection. The ball first hits the ground at point B, where AB is 120 meters. So this is the range, how far the ball goes. The motion of the ball is modeled as a particle moving freely under gravity. The initial speed is u. So we don't know the value, but we know this is called u. Then using this model, show that u squared sine alpha cos alpha is 588. So remember that in the projectile questions, we can work with horizontal motion independently of vertical motion. The horizontal motion is going to be a constant velocity motion because we don't have horizontal, or we are ignoring them, horizontal forces, so we will have horizontal acceleration. And the constant velocity is going to be the horizontal projection of this velocity, which is u cos alpha, because this is adjacent to the angle, so I'm just considering this triangle. And the vertical motion is going to be under gravity, so a particle moving freely under gravity, and this is the initial velocity. It's going to be u sine alpha. So if I work with those things independently, for A, my horizontal motion is going to be constant velocity. So this is the formula for constant velocity. My velocity is u cos alpha. My total distance is going to be 120, and my total time, I'm going to call it with capital letter T to distinguish from the variable. So I have one equation here that relates T, alpha, and u, but I don't have enough. So what I'm going to do is to work with the vertical motion as well. Vertical motion is it's just a particle that is moving freely under gravity. So it's going to be projected up and it's going to go down. This is A and this is B. And this is GR12 moving freely under gravity question, yeah? So it has nothing different. I have initial velocity is u sine alpha. So I'm going to use subat. If I write subat, and remember when we work with particles moving freely under gravity, we choose a positive direction. It doesn't matter which one, but you have to just be consistent with it. So I'm going to choose positive up. Displacement, if I consider the whole motion from beginning to end, displacement is going to be 0 because the particle starts and finishes in the same place or the same height. Initial velocity is this u sine alpha. Final velocity, we don't need it. Acceleration is going to be the gravity, but I say positive is up and my gravity is always down. It doesn't matter how the particle is moving, the acceleration, the gravity is always pointing the earth, so it's always to be down. So I have to write that is minus. And the time is the time. So I'm going to find a subat equation without v, because I don't need v, which is this one. S is ut plus 1/2 a t squared. S 0, I'm just going to substitute u sine alpha t, then minus because acceleration is minus, and I'm going to halve it, so 4.9 t squared. When we factorize this equation, we have t u sine alpha minus 4.9 t equals 0. We have this value equals 0, where the particle is here, and then this bracket equals 0, which is when the particle is here. So I'm going to ignore this value because I'm interested in the whole thing, the same that I am interested in the whole thing for the horizontal motion. So I can write that u sine alpha is going to be 4.9, and I'm going to write t, capital letter T, because the time here is this time here, which is the same than here. So the particle is moving the same amount of time horizontally and vertically. It's the time that the particle is in the air. So with this equation and this equation, I'm going to eliminate t and find a connection between u, sine, and cos. And it's going to be what they are asking us to prove. So for example, in the first one, so in number 1, I'm going to make t the subject, and t is 120 over u cos, and I'm going to substitute in the other one. So I have u sine alpha is going to be 4.9 times 120 divided by u cos. And I think I know know where we are going. So I multiply everything by u cos, and then I have u squared sine cos, and when I multiply 120 by 4.9, I have the 588 that I needed. Yeah, so this is my first part of the question. This is the equation that I had to show. Then for B, they say the ball reaches a maximum height of 10 meters above the ground. So the height here is going to be 10 meters. And I need to show that u squared is 1960. So if we are talking about maximum height, we are going to work again with vertical motion. So we are going to work with subat. And we are talking about the particle going from here to here. So maximum height. When that happens, remember the velocity is 0 because the particle goes up, stops, and then accelerates down. So if I write my subat again, considering positive up, the displacement at the top is going to be 10 meters. That's my maximum height. Then the initial velocity is still my u sine alpha. Final velocity at the top is 0. Acceleration is minus 9.8 again, and we don't need the time. So I'm going to look for a subat equation without time, which is this one, and substitute. So v squared is 0, u squared is u sine square, and then minus 2 times 9.8 is 19.6, and then times 10. So I have that u squared sine square alpha is going to be 196. So you can consider this equation here, and I write in another color so you don't get confused with the top equations. I have one equation here with u squared and alpha, and another equation here with u squared and alpha. So the only thing that we have to do to find u squared is to eliminate alpha. I can write this equation, the second one, as u sine alpha, just doing the square root of the whole thing, equal 14. That's the square root of 196, yeah? So I have two equations, and I think you are going to see better here. U squared sine alpha cos alpha is 588, and u sine alpha is 14. So if to eliminate alpha, what we can do, for example, is u sine is 14. So from here I have u times u sine. So I'm going to have, I don't know if you can see that, but this is u times u sine. Just this bit here. Which means that this is 14u. So this bit is 14u cos. Yeah, so I can write that as 14u cos alpha is 588, which means that cos or u cos alpha is 588 divided by 14, which is 42. So between this equation and this equation, I can write the 1 squared, u squared sine squared, plus the other square, so u squared cos squared is going to be 14 squared plus 42 squared. So I'm just squaring both equations and adding them together. So the left hand side is going to be u squared sine squared plus u squared cos squared, and the right hand side is going to be 14 squared, 42 squared. This thing here, using the identity, is going to be just u squared, because sine squared plus cos squared is 1. So I have u squared is going to be 14 squared plus 42 squared, that is 1960 as they ask. Yeah. So it's really up to you how you solve these simultaneous equations. You just have to eliminate alpha. I did it one way, you can do another way. But the important bit is that you are able to write an equation that allows, together with this one, to eliminate alpha. Yeah. And now it says the motion of in a refinement to the model, the effect of the air resistance is included. The motion of the ball from A to B is now modeled as of a particle moving with initial speed v instead of u. This refined model is used to calculate the value of v. State which is greater, u or v giving a reason. So we are not changing anything else. We are just changing the initial velocity and including air resistance. I know your first tendency is to think, if I'm including the air resistance, the ball will go slower. But what you have to think is that nothing else is changing. So the ball, this range is going to be the same. The ball is going to be as far as it was going before considering air resistance. And you are thinking how fast you have to project the ball. So if you are including air resistance and the ball has to be as far as it was before, you have to project it faster. Yeah, so V is going to be greater. And I think there are more questions that they have asked that, and it's not unusual that you say the other way around. So V must be greater if you are including the air resistance to reach the same distance. Yeah. And then no, that was C. And D, state one further refinement to the model that would make the model more realistic. I would always recommend in projectile questions or motion under gravity, if they ask you to give or to suggest a refinement of the model, you always can say use a more accurate value of gravity, because it's just simple, and you are going to get the marks. So this was C, and D is more accurate value of gravity. Something like this. You can say things like consider the volume or the shape of the ball, but this one is one easy mark. Yeah, and that's all with this question really.